We got Barry's freshly acquired LS swapped 65 Impala in the shop here. We're going to do some updates to suspension, address a few issues we found with the build, and maybe add some power in the process. Stick around. So a month or two ago, Barry drove down to Iowa. He's from Wausau, Wisconsin, so it was kind of a hike for him, but went and looked at this car and decided it was right for him and picked her up. It's got a pretty nice matte black paint job, and the bodywork is laser straight on it, which is kind of hard to pull off in this color. Don't mind the dust. That was from me hauling it over here on the trailer. But pretty nice car overall. Interior's in really nice shape yet. All original. But what got the conversation started between Barry and I was, I don't know if this thing's got big block springs in it or what, but the front of this car is nose up really hard. And being LS swapped, even lighter than a traditional small block, that made it even worse. So to correct that, we decided that we're going to do some CPP 2-inch drop spindles, some tubular arms, and some Alden adjustable coilovers in front. Also, this car has drum brakes up front, so we're going to take care of that right away. And you see there's a oil pan and maybe a little camshaft laying over there yet. And oil pan is because, well, that's pretty self-explanatory there. That's asking for problems all day long. And after we lower it 2 inches, gonna have about 1.5 inches of clearance to the ground with that. So that's a mandatory upgrade. And under the hood here, she's pretty crude, so we're gonna tidy this up the best we can here while the motor's out. We'll try and tuck the harness and clean some of this mess up. There's also some other issues to address. As you can see, they've got the Agent Orange all over the thermostat housing there. I had to dump a gallon of coolant into this thing to even take it on its initial road test. Also, when I picked the car up, Barry had made mention that the transmission didn't feel quite right to him, so that's what provoked the initial test drive of this thing. I connected my HP Tuner software and data logged all the transmission parameters and saw that the force motor current was stuck at 90%. And ran the codes. I think it's a P0784, something like that. But transmission pressure control solenoid circuit. So armed with that code, found the ECU stashed behind the glove box insert here. I disconnected the ECM and tested the 2 pins that go to the force motor. The force motor controls line pressure in the transmission. But there's supposed to be a certain resistance value on that solenoid, and you can test it all the way back to here. And testing those 2 pins, I got an open circuit, no resistance at all. After unhooking it here, I unhooked it at the transmission and tested continuity from those wires from the computer to the plug. And after testing between the ECM and the transmission plug, them wires are all good continuity. I plugged in, I got an extra pigtail harness for these transmissions, and tried to test the resistance right here with the known good brand new harness, and it still shows open circuit. So the next step is to drop the pan and see if it's either the internal transmission harness or the solenoid itself we've got issues with. This is pretty typical for these 406D drain plugs. It's completely stripped out. If yours still got a hex on it, put a little heat to her. That might be enough. Get yourself a good sharp chisel. At a corner. A great big blunt one now. Hook my notch I made. There we go. So it looks nice and clean. Yep. Come on, baby. Boy, you sure are struggling with this. There we go. Well, there's the problem right there. Yep, that'll do it. Wire was pinched between the pan and the pan rail there. And this is the force motor right here that controls line pressure that we're having codes. Oh, look at that. It even pulled the pin out of the connector. Ha! Ain't very often you catch something like that real time. I don't know if that'll snap back in there. I don't know, I'll have to pull the harness out and see if that'll pop in there. If not, we'll have to replace this internal wiring harness. It's a shame too, because it is new. I mean, all these connectors look like brand new. Thing looks pretty nice inside. New solenoids. I see it's a new lockup solenoid there. And I know we found the problem, but just for due diligence here, we're reading within the ohm spec, 2.5 to 5 ohms. Well, we talked to Barry, and the whole idea with doing this transmission first and trying to figure that out was, if we didn't have to go in there and rebuild that thing, there'd maybe be some money left in the pot to replace this crusty old exhaust here with something a little better looking, a little shinier and newer. And I'm confident we've got our pressure control solenoid issues sorted out there. But the only thing that concerns me is I had a super firm 1-2 shift being at full line pressure with that solenoid disconnected in the pan. But the 2-3 was left something to be desired. So he wants to do a shift kit in this thing, and at full line pressure with a soft 2-3 shift, that leads me to believe that there may be issue in there. I mean, the pan was super clean inside, but maybe there's a whole bunch of clearance on the 3/4 clutch pack. So we're gonna pull everything out. I need to pull the whole works out anyways, because that servo cover is mashed up against the floor pan. I can't get that out anyways, and anytime we do anything with the 4L60, that's about the first mod you do, is put a vet servo in it. So yeah, when it's out, I'm gonna pull the pump and the input drum and check the clearance on 3/4 clutches, and maybe throw an extra 1 or 2 in there if I can get them in. He also had made note that this thing has a wicked vibration just off idle, and that probably has a lot to do with it right there, that rubbing on the floor pan. That in conjunction with solid motor mounts and the oil pan hitting the frame. So we'll address all those things while she's out. Time! Just under 2 hours, I got everything completely disconnected. Exhaust, transmissions, unbolted off the cross member. She's ready to get pulled out. Just need to get this hood pulled off of here. I've got the front bolts out already, and Scott's on his way over here. Give me a hand, he'll be right on time. Well, off camera, I cleaned this thing up, painted it, installed the oil pan, the camshaft. I didn't do any of this stuff on camera because so many of my other videos detail all that stuff. So check out one of my other builds and you definitely see it. I don't pull the heads off. I either flip the motor over or shove dowels in if it's installed in the vehicle to hold the lifters up. But anyways, something I have never mentioned before on the channel is this cam isn't big enough to warrant aftermarket push rod. It does have LS6 style 550 lift springs, but when you take the push rods out, you see the tips of these are nice and shiny and polished, and this one here, you can see it kind of looks like it's sanded or ground on. See this all the time in these motors, and if the push rod looks like that, it'll be on the top side. This is the corresponding rocker that came off that. Now compare that right side rocker, the pocket, to this one. You can see that damn magnetic tray. This one is wore in quite a ways, and that will continue to wear because the surfaces are compromised. So I'm gonna have to replace a couple rockers and a couple push rods. I've got all kinds of that stuff laying around here, so not a problem for me. But yeah, be aware of that. If you see wear like that on your push rod or rocker, you're gonna have to replace those items. We got our motor all put back together, wrapped up, ready to rock, and we made some new discoveries here. So I was looking at this transmission, and see down in this connector, the pin retainer and seal assembly's gone. See this green portion, this is a 4L80E harness, but same thing. That green part snaps in there, and that's what retains the pins. I mean, I can just push them right out into the transmission. And the white part of that is the actual seal. It seals the pins and the connector to keep all the weather out. So you get any water on here, it's going to run right into the transmission. Not good. So I'm kind of glad we pulled it out because we couldn't see down in there with it up in the car. And also, I found another spot. I was rubbing the floor here, and there's this weird yellow residue all over everything. And I see in the engine bay, there's kind of a weird film of I don't know what all over the place. And the more I looked at it, I figured out must have had fire in here at some point, because the O2 sensor wiring is all charred up. The harness is all up there, is all burned. I mean, not burned, but there is clearly a fire there. And I think that's due to the fact that it's got these rubber fuel lines on it. And I mean, service life of these rubber lines is maybe 4 years if you're lucky before they start coming apart. You see up in there, lines are all cracked to hell. And another funny thing is they've got this vet filter regulator set up on here. So there's a regulator here, plus a double line going up to the rail where there's another regulator. So God knows what kind of fuel pressure this thing had. Way low, I would imagine. But these things are garbage. Do not use them. I've taken 4 of them off of customer vehicles this year. Fuel pressure is ranging from 40 to 90 psi, so just stay away from them things. Also here on the oxygen sensor, this has got the black square 4 LS1 style connector, and they've got a different style here. This would be a little later truck cell O2 sensor, but you see they just ground the tab out so it'll plug in there. Well, the difference between a white plug and a black plug is case grounded or not case grounded sensors. So I did see on the scanner on the test drive that the O2 sensors were not functioning, and they couldn't if they wanted to because it's a completely different sensor. So we'll have to put the correct sensors back in here. So with those new discoveries, we see we got some more parts to order and other issues to address, but I think for now we're going to get cracking on this front suspension. I'm going to strip the whole works out, maybe try to clean some of that engine bay up a little bit before we start putting stuff back together. So let the teardown commence. How's that for a before and after? Took some time and cleaned this frame all up. A little wire brush, wire wheel, some rattle can overhaul, and the inner fenders, firewall, all that stuff. Courtesy of Mr. Clean, some elbow grease, and then a little bit of spray wax after that. But got her looking pretty nice. Figured we got the motor out of there, let's make her look like something, huh? Well, before we can get rocking and rolling, putting the suspension back together, we need to make some modifications. And these lower control arms, since we're going coilovers, we don't need the isolator. And when you go to coilovers, it moves the mount from the bottom of the arm to the top. So you need to knock these nuts off and grind that smooth. I didn't have to drill them out any bigger, but normally you'd have to drill them out to 3/8. And the steering arms we just took off there. You can see it says you have to remove an 1/8 inch of material off the backside, off the bosses here, or else they'll interfere with the control arm in some way. Buddy Chad from Crooked Iron Fab's on his way over here. He's going to pick these up and put them on his mill and take care of that for us. We also need to address these strut bar mounts. You see they're rotted out there behind where the bushing was. Both sides are like that. I've got new bushings, but yeah, they're not gonna stay where they belong, so we're gonna cut that out and plate that back in. We'll jump on the computer and draw something up for Chad to cut out on a plasma table. Well, that wasn't too bad to take care of. I think they turned out pretty good. It's just kind of a poor design there that water gets down between there and no way to get back out, so the rust just grows in there and builds. That metal that was left there was just paper thin, and yeah, not a good situation when it mounts your critical suspension components. But I had Chad buzz me out a few extra sets. They'll be on the website for sale. There'll be a link below for those. He also got our steering arms milled off flat for us. Don't be tempted to take a grinder to them. Take them to machinists, get them cleaned up, parallel, flat. Linda? But now we can get our suspension put back together. a wrap on our suspension install. Get everything back on besides for the dust caps on our hubs, and I need to leave those off in order to put my caster camber gauge on there. When we get the drivetrain back in, we'll put a initial alignment on this thing. And also, while you guys weren't watching, I jumped ahead and replaced the proportioning valve in these few brake lines here, and got everything bled out. That's something that gets often overlooked, is the proportioning valve. This is a drum style, and we switched her over to a PV2, which is front discs, rear drums, and if we had four-wheel discs, it would need a PV4 style. Well, it's been between 20 and 15 degrees below zero Fahrenheit for you metric types for the last 3 or 4 days, so finally got a decent day out here. It's like 20 degrees above, so we're gonna clean this transmission up. I'll clean the accessory brackets up too, but I don't like taking these things apart when they're all grimy and nasty. So I'm gonna blast the bell off and get this thing steam cleaned. And don't forget your H's Performance wash plug kits on the website. Get you some. We got the pump, reverse input, and the input drum assembly set up on the bench here with the indicator on it so we can air test it and see what clearance is at. I can tell just by looking at it, focus, the clearance to the snap ring there. I can see it's way more than what it should be, and the band is glazed a little bit. The drum's okay, but we're gonna have to put a band in it. So we'll air test this, see where it's at. See, there's some spring back here, but if I compress it all the way, she's zeroed out. We're gonna put air to it and apply the clutch pack, see what we got. About 90 thou. That's about 3 times more than I like to see on that clutch pack, so we'll pop her open and see what they look like. Burned. That's looking more like it. Upgraded this to a 7 clutch stack. Completely rebuilt the whole works, rebushed everything. Got the pump cleaned up. All my pump components are in there, ready to go back in. And bushings. Rebushed everything in the trans, as well as tore the valve body down, got that all cleaned up. And that'll get a bunch of these Sonax components. As well as we got our new band here, new HT sun shell, vet servo, and the rest of our parts here squeaky clean out of the hot washer, and everything's rebushed, ready to go back together. Get back in your home. Trans is rebuilt with H's secret blend of special herbs and spices added in. Let's get this thing back together. We're getting things hooked back up, reconnected underneath here, and ended up moving these motor mounts ahead one set of holes, which is only what, ½ inch or so. That corrected our issues with the bell housing hitting the tunnel and got the servo cover off of the floor pan there. And truth be told, I think that might have had something to do with the demise of the transmission, because the servo cover was hitting the floor pan. And it doesn't take much pressure on that servo cover to apply the band in there, so it could have been dragging the band the whole time. So I was shoving that motor ahead that ½ inch. We ran into issue with the drive shaft here. With that all put together, here's what I had for yoke engagement in the transmission. Now we only moved the motor ½ inch, so you can see the line where it was before. And I mean, that's not adequate as it is. It's probably only that much engagement into the bushing and the tail housing and the transmission. So instead of retubing the drive shaft, because obviously you can't just weld a little piece in, that's pretty expensive to have done, or get a whole new drive shaft altogether, dug through my plethora of yokes and drive shafts outside my drive shaft pile and found this shaft out of a early 90s Chevy pickup, two-wheel drive. And this has got a 5-inch barrel on the yoke. In addition to that, look at where it starts here compared to this one, the offset from the base of the yoke, I guess. So that'll put us well within the bushing, get us sealed up into the tube seal, and make everything hunky-dory. I will have to get a conversion joint. This shaft's a 1310 joint, and this is a 1330, so I have to run to town and get a bastard joint for that. Much better. I'll chalk that up as a win. Crisis and dollar signs averted. Yeah. Moving right along here. Pulled the old rubber fuel lines out, and look at these things. They're rock hard, and if you try to bend them at all, yeah, not good. See, somewhere on these, they're in the label, they're 2018, so they're not super old, but yeah, they just don't hold up. And here's what we replaced it with. Some nylon line, should outlast the car essentially, and replaced the fuel filter, got rid of that Corvette style regulator. Also had to drop the fuel tank. Barry had said the fuel gauge wasn't working, and I had to change the fittings and stuff up there anyways to get some quick connects put on, but I diagnosed the fuel gauge that wasn't getting a solid connection to the tank itself, so that should all work now. And chipping away at the top side here. Got a bunch of stuff hooked back up. Get the air cleaner put back together. I did end up having to replace both of these boots because, well, I could show you what was on here. That tube was only in, well, maybe half of the clamp engagement, and this one was even worse. So this is a straight boot, and it didn't even have an 1/8 inch of engagement between the mass air and that tube. So you got a 15-degree boot on there now. I make those for the Trailblazer SS style intake manifolds to straighten that angle out what comes out of the intake. And of course you got to put your name on it, right? Also getting the cooling system put back together here. Got some molded heater hoses there and a proper mount, and going back with the radiator lines with some silicone couplers and aluminum tubing. Got the lower one there, and this was what was on the upper. Masterpiece there. And look at how much engagement was on this hose clamp. Not very much. So yeah, see you later. I've got the lower figured out here. I've got to pop that one back out as well so we can roll some new beads back on the end of these tubing. Got our coolant lines all wrapped up there, and I really like using these Gates Power Grip heat shrink clamps. Really cleans everything up, and then these stainless band type clamps, just a lot cleaner look. And I also used all of them on the intake tubing as well. And next up, we're going to get this wiring taken care of. We're going to re-lume all this and make sure everything's okay. Everything's all burned and charred up there, so we're going to rip all this lume off and put some nice lume on there and rewire the fan, because it had this Mickey Mouse fan controller set up in it, and it had a sensor that went into the block, and yeah, I don't like it. So we're going to go back to a regular 4-pin 40 amp relay. Well, this is a 5-pin, but same thing, and let the ECM control it like GM intended. Well, we got everything hooked back up. We're loading in a base calibration on HP tuners right now, and we're ready to hit the key, see what happens. We'll get the scanner fired up here and hit the key. Ooh, that sounds nice. see anything running on the floor. That's a good sign. Percolating. Got a little heat in her. 171 degrees. And look at that. Our O2 sensors are oscillating. I got our initial fuel settings pretty close there. Within 4%. Got a nice little lope to her. Would you look at that? Brand new set of 17-inch torque thrust. And about all the meat she'll take in the back. And what have we here? Well, Barry decided to pull the trigger on this 2.5-inch pipe stainless kit. The X pipe. This is cross member back. And to get up to the headers, we've got a section of 2.5-inch stainless with U-bend, couple miscellaneous bends, and we're going to cut those 3-bolt flanges off the headers and put some proper V-band flanges on them. So I guess it's time to start ripping and tearing on this nasty old exhaust. Out with the old, and in with the new. You can see why this sounded kind of like a Alice Chalmers. They didn't weld on top of the pipe there. Pretty bad leak on both sides. I guess it was too much work to drop the exhaust hanger down and finish that weld up. But hey, let's get this new exhaust on. Alright gang, here's where we're at. I started recording this on time lapse, but there was so much screwing around back and forth, readjusting stuff, that it took a couple hours to get everything situated the way I wanted it in here. And I guess the only thing I deviated from what the, well, if you could call them instructions, there's a couple pictures online to show you how it goes together, but I added a couple hangers here because the only hangers they supply is one that goes here and then right at the muffler there. I guess the major takeaway from putting this on is start at the back and work your way forward. And I think on the next one I'm going to push for a MagnaFlow kit because, yeah, the fitment really wasn't great on it. But I got her up to the X. I've got them, you hear me jingling around here to show you these clamps that they supply. Check out the fit on these nuts. Yeah, so the clamps are good. I had to replace almost every nut that they were supplied with because it would strip out before you even got 5 foot-pounds on it. But yeah, I got these pipes trimmed up. I had to cut about 6.5 inches off there to hit my notches, and now it's time to pop the headers off of there and get some V-band flanges welded on them. We got her all welded out and put back on there. We did ditch these janky exhaust clamps and put some nice stepped stainless band clamps on there. clean her up a little bit, won't leak so much. I also went ahead and welded these joints out on the back of the X because there's no reason that needs to come back apart. But got band clamps back there on the muffler, and got some traditional clamps back here yet just because the hangers are there. But let's see what she sounds like, huh? No leaks like that. That's gotta be about it for this thing, ain't it? Not quite. Well, Barry wasn't all that thrilled about the open rear end in this car and didn't want to invest money into the 10 bolt, so he got on the face space marketplace and acquired him this here 12 bolt. Now, it didn't look near this nice when we got it, but after some blood, sweat, and tears, we got her looking pretty nice. Everything inside was a complete loss, even down to the yoke. Here's some short clips from that process, because I didn't go into depth of taking video of all that. Alright, this is the first. Gutting this 12 bolt for the Impala. Check out this pinion seal. I can't say I've ever seen that before. Well, that's what it did look like inside. Just full of rust and crap. Attacked her with the old steam cleaner, got her looking pretty good. There's a bunch of rust in this axle tube. I think I got her. And right here's the secret weapon to clean all that rust out of them axle tubes. Put that sucker on the drill and let her eat for a while. And here's that yoke. I sandblasted it to try and salvage it, but yeah, see, it's awful pitted up there. And here's what we got going back in. We've got ourselves a Yukon Duragrip, Excel Richmond ring and pinion, no used yoke, set of Moser axle bearings and seals, install kit, and a new set of Moser axle shafts. Now these full-size Impala 12 bolts are a little bit different animal than your garden variety like a Chevelle 12 bolt. I learned a little bit sourcing parts here. They use the bigger axle bearings like would be in a 63 to 72 12 bolt Chevy pickup. And the axle shafts are actually the same as what's in the pickup, just re-drilled for the car pattern. So there is some small differences there. There's some differences in some of the ears with the pinion seal as well. That yoke actually came out of a truck rear end, and the pinion seal is right for it. So just some stuff to be aware of. Well, I guess that's probably enough rambling for now. We're just going to blast through putting this axle together on time lapse. If you want to see a step-by-step instructional video I did on how to set up a ring and pinion, I'll leave a link for that up here. So here's what I believe the last piece of the puzzle is. Barry didn't have no speedometer here. Now, we could have made this work with one of those Speed Hut speed boxes. It's GPS driven, and it actually turns a speedometer cable. I've used those in the past. They do work. But they are kind of expensive. They're like 350 bucks. And Barry didn't want to spend the money on a Dakota Digital setup. I mean, their stuff it's $1,000 for the cheap one and like $1,700 for the fancy setup. So he brought these over and asked if I could make them work. And they got everything you need: oil pressure, coolant temp, fuel gauge, voltmeter, and the speedometer is GPS driven. And that'll enable us to get rid of this here Boomer starter pack too, hanging off the dash. So if we're putting these gauges in here, the issue I see right away is these things are a lot bigger than what the opening is. So you can't really sink them down in there. And I'll flip this thing over. You can't really open this up in here, cut down in there. You get into this gray trim portion, and I think that would look, pretty hack job if you did that. So let's get on the computer and see if we can figure something out. So the first thing I did here is take a picture of that thing with a tape measure in the frame here for scale. It's kind of neat in Fusion. You can calibrate your drawing here. I can click anywhere on the picture, and 5 inches there and 15 inches here, and tell it that it's 10 inches or thereabout. So that gets you real close for scale right off the bat. From there, I created a sketch and kind of got the outline here, the general shape, and got the bolt holes where they needed to be. And with that, extruded this ring, and I made probably 5 of these, real thin with the 3D printer, just to make sure I got the bolt hole right and the outer profile. And here's all those test pieces I did. Just kept moving the bolt holes around and just kept dialing it in until I got it perfect. And here's where we end up with that. Got these spacer rings, and I had a couple little spots where it's yellow here. There's a little tiny bump I had to grind off there, and there's one on the other side as well. And where I've got painted yellow here and here, I had to lightly sand that off to get everything sitting flat here, so that wasn't sticking up above my flange. Being that these gauges are bigger than what our opening is, my thoughts were we could cut the bottom of this off, offset the gauges down in the opening and still be able to see everything. So something like that. From there, I created another set of sketches here. We'll get this canvas out of the way so you can see what's going on in this flange. And I kept moving these circles around to where it was visible in the through the bezel there, till I got it how I liked it. I went through, I believe, 3 iterations of that before came up with a final design. So this is version 1 here. It's kind of thick and chunky. The gauges weren't in a very good spot with this one. They were too high up yet. Here's version 2. You can see I moved the gauges down quite a bit and trimmed some of the fat off it so we weren't wasting so much material. Here's version 3. This is pretty close to where we ended up. This hole was kind of tight, and I forced the gauge in and ended up breaking that one. And the print didn't turn out that great on this one here. Here's what we came up with. Got the gauges sitting where they need to be, and put a couple little features in there so it wasn't such a big, wide, flat expanse there. And this is what it looked like before it printed here. That's all support structure. And this is what it looks like when you print something like that. And here's our finished product. Also made these delete plates to get rid of the old fuel gauge, and the dash clock didn't work anymore. So blanked them out with some Impala logos. And here's what we're looking like installed. Not too shabby. We got our delete plates in there to get rid of the old gauges and the old clock, along with our brand new custom auto sound retrofit radio. I'm liking it. Well, we're rocking through our final checklist here, getting ready to get this thing out on the road and get it tuned. And I found a little issue back here. I was greasing this rear joint, and I see we've got ourselves a leak starting. And upon some research, I figured out exactly why. We're going to have to pull this yoke off. I did mark the position of our nut, so we can take this apart and put it back together and get the exact same tension back on and not screw up our pinion bearing preload. So I'll get that yoke popped off of there and show you what we're working with. With that yoke off of there, you can kind of see what's going on here. You can see the seal is basically touching the outer pinion bearing there, which means when you tighten everything down on the yoke here, that seal is actually riding on this chamfer. And that's because there's a variation, like I had said before, I think, between the car and the truck pinion seals. The truck housing is a little bit longer here to leave more room for the seal, so the seal is made deeper. Well, the car one doesn't exist anymore, so all you get is a truck seal. And to remedy that, you drive the seal in and you leave about an 1/8 inch gap. Well, doing it that way, it's be really easy to get that seal cocked in there crooked. So to combat that, I've got a new seal here, and I've 3D printed a 1/8 inch tall spacer ring that sits on there perfectly, so I'll be able to drive that in till that bottoms out, and that's solid polycarbonate, so it's not going to melt or crush or anything like that. And there we've got our ring and new seal installed. And I also like to throw a little bit of this anaerobic schmooey around the perimeter of them seals before I drive them in. It's a little added security. Yeah, I'd say we got her sitting right. Well, we made her through our final checks, our punch list. Got a preliminary alignment on the front end so we don't chew up Barry's tires. And we're just waiting on my buddy Jeff to come over here and help me put the hood back on this thing. And we'll get her tuned. Working way through the tuning process here. We've pretty well got the narrow bands in check here. I like to do the narrow bands first, just low throttle inputs, just so we can get drivability down first, and then we'll transition into wide open throttle tuning with the wide band. But I'll bring you live here for a second just to show you how this transmission shifts. It really snaps the shift off nice, and I have done nothing to the shift modifier tables to add pressure or anything like that. Nice crisp shifts. That 2-3 is super positive. Here comes the 4th gear shift, and then the converter lockup. Wind noise. Yeah, but for now we gotta head back to the barn. Laptop's running low on juice, and it's 6 o'clock at night. The whitetails will be out in full force. And yeah, like I said, whitetails. These are right alongside my driveway here. Well, after our initial test drive and getting our low-speed fuel trim sorted, the brakes were not great, and did a little research. You see we got a brand new master cylinder on there. This thing did have a dual pop master upgrade on it already, but it was a 1-inch bore, which is size 4 drum brakes. We've now got a 1 1/8 bore on there, and the brakes are feeling a lot better. This is factory optioned for a 69 Impala, which was the first year that disc brake came standard on these cars. So we'll see how this one works at speed. And got the wideband hooked up. I popped out this O2 sensor and hooked my wideband up. We just flashed in a file to disable the fuel trims so we can get some wideband tuning data. Not a show. Got some pretty good data on that trip. And as you see here down below 2400 RPMs, it's showing like 28% lean. We're going to throw all that data out. That's in a throttle transition area where the cell just hit a couple times in there and didn't hang out there long enough to get any good data. I locked the car into third gear and made a pretty good pull there. It stayed right at 95 kPa, and I can interpolate out from both sides of that road to get the rest of our fueling. But yeah, everything 2400 up we'll keep, and the rest of it we'll throw out. And we'll get our VA table dialed in here. And we needed to give this thing a little break because trans is at 196. I try not to push them much over 200, so we'll give this thing a little bit of a break and resume when she cools back off. We're back out here. We have completely finished tuning the VA table. Got fueling within 1% up top, looking really good. And now we've re-enabled the MAF, and I fired the car up on the stock table, and it wouldn't even register on my wideband gauge. It was full lean, so I just whacked the entire MAF curve with 15%, and it's somewhat close there. So we'll go for a little drive here and start logging the MAF channel and get fueling dialed in on that. Once we're done with that, we'll re-enable dynamic airflow, and it'll read off both the MAF and the VE table simultaneously. Well, I made her about 3/4 of a mile here, and I see it's still wicked lean. About 15%, trending up towards 20%. Idle area is good, and I was super light on the throttle. So let's see, about 4,000 hertz and up, we're gonna give her about 15% here on the MAF curve. Where are we at? 4,000. I'll grab this whole table. Times 1.15. That'll bounce that up 15%, and then we'll just interpolate back to that idle cell, which was about 3125 hertz. Just like that. Put a save on that, and we'll flash that one in. Well, we're getting there. We just ain't got her quite yet. When we were out tuning the other day, it was about 85 degrees out, and coolant temp got up to about 210. And I let the car idle for a solid 10 minutes, and the coolant system would just not recover. It's got a 180 degree thermostat in there, and it would not pull the coolant temp back down. So We got rid of the old 14-inch, eBay, Amazon fan. Cut the shroud and put a 16-inch spal fan on there. This is probably double the CFM of that, so that should take care of our cooling woes. Also, while the coolant temp was at like 210, and I was reading that off at my HP tuner scanner, this temp sensor in the block and the gauge in the dash was reading at like 240, close to 250, and we don't want the gauge to be showing that it's overheating all the time, so I got a whole bunch of different resistors here, try to determine what resistor value that temp sensor is, and by plugging these in, I figured out that 150 ohms gives you 140 on the gauge, and all the way down to 22 ohms is what maxes it out. I got on ChatGPT and it built me a thermistor chart for this and figured out that I need to add a 22 ohm resistor in line with that sensor. Should make the gauge read right. So we're going to give that a try, see if we can get that gauge reading a little more accurately. Hey, look at that. We're at 180. And we're at 180. Love it. Well, that concludes fueling tuning. Time to sprinkle in some timing. So girl ain't no slouch. Well, we're back, and it's hot out, about 85 degrees today. 185 degrees after out giving her. The fan is a little bit noisy, but hey, if it keeps us cool, that's all that matters. Well, I think that's pretty well going to be a wrap on Barry's Impala here. We got the tune dialed in. She shits and gets. And we'll throw some pictures up to remind ourselves what it looked like underneath the hood of this thing when it showed up. And what we did to the overall stance and look of the car. I'll also make note that we did go back with this 1-inch bore master cylinder. With that 1.1 on there, pedal effort was just too much. You needed 2 feet to even stop the car. In order to make that work, we'd have to upgrade this brake booster to a dual diaphragm style and upgrade on that. But I had a little bit of air in the system yet, so they're working pretty decent now. Well, if you guys made her in this far, thanks for sticking around. And a huge thank you to Barry, the owner of the car. He's been an absolute dream to deal with, just an awesome customer. Thanks, Barry. And a lot of you guys been asking about the 50 Chevy, what's going on with that? Well, we're going to jump back into that next, so stick around the channel, and we'll see you on those videos.